Okay, good evening, everyone. So today we will discuss about like how a production environment looks like, and if you are planning to host a web application, and what are the things we have to take care, and how to create that infrastructure to be highly secure or highly available. In that particular case, we will take an example. Like you can take any example of any application, and here what I'm going to do is I'm going to take an example of WordPress application to deploy. Do you know what is a WordPress application? That's a kind of a content management system that can be used for different cases, like for different applications, they will use that. Generally, we don't decide what application, and we are not responsible for maintaining the application or to configure the application. That will be taken care by the application team. And what they will give you the requirement is, we would like to host a WordPress application. And to host the application, we need these many requirements. So first, what they say is, we need that application to be highly available. That must be highly available. And that must be highly secure. And that must provide high performance also. These are the basic things they can provide. According to these requirements, we need to create the infrastructure. To run this application, it requires some kind of a platform. And to install or to create the platform, it requires an infrastructure, right? So in order to decide what kind of services to use or what kind of infrastructure to create, first we need the requirements about the application. What kind of web server it will use, and what kind of database it requires, and how can we maintain the high availability of that application. All these things we need to decide. What they provide is what kind of web server it is required and what are the minimum requirements. It might require some kind of a dependencies, right? Let us say if you are hosting a .NET application, then it might require Microsoft IIS web server and Microsoft SQL database server. So the application team will provide what kind of web server it requires and what is the version of the web server and what type of database is required and what is the version of the database. They will provide those requirements. Based on the requirements, we need to decide the infrastructure, like we need to design the infrastructure to provide all these facilities. So we don't have any application team, so we need to identify to deploy this WordPress applications, like what are the requirements, what type of web server it is required, and what kind of database it is required, and all the things. So for that, what I do is I will go to WordPress website. And if you go there, and from here you can download and install, but we are not downloading it right now. Just we are trying to collect the information, whatever is required to deploy that application. Let us say you are going for something else, like a .NET application, then the requirements will be varied, but the underlying infrastructure or the architecture might be the same. So you can see that to run the WordPress application, the requirements are as follows, which is it must require the PHP version must be minimum 7.4 or more than 7.4. You cannot use PHP version 7.2 or 7.1 or something to run WordPress 6.0.1 application. And it requires the MySQL database version must be minimum 5.7, or you can go with 8.0 also, that doesn't matter, but minimum to be 5.7. But in the real time, they will give you the exact version also. We need 8.0.5.3 or whatever it is, they will give you the number for that version also. And in the same way, for the PHP also, they will specifically mention the version number of the PHP. And then it requires either MySQL database or MariaDB. So the application team and the development team will decide what database to be used, because at the time of development, they will use or they will design the application to be used with some database, right? You have to use the same application. And these are not required here, like Nginx or Apache as a front-end server. So generally, you have to install each and every component manually to run the WordPress. But we have a package called XAMPP, 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 which can be downloaded for free, in which you will get Apache, PHP, MySQL, and PHP-MyAdmin. All the required things to run the WordPress application is available with this particular package. If you don't want to use this package, you have to install each and every component manually. PHP is mandatory, MySQL is mandatory, and the Apache. These are the mandatory components. So here, what we are going to do is we are going to use the XAMPP application to create the platform, so that on the XAMPP application, we will host our WordPress web application. But the first thing is the WordPress application must be highly available and it should provide high performance. For high availability, you have to use the web servers to be running across minimum 2 availability zones. And to distribute the load across all the servers, we have to use a load balancer, right? So we have 4 different types of a load balancers. What type of load balancer we have to use? That we need to decide, because the application team or developers don't mention or they don't know about what type of load balancer is available on AWS. So we need to decide. So we have an application load balancer, network load balancer, gateway load balancer, and classic load balancer. So which load balancer to be used for this requirement? Application load balancer, because the web application runs on 80 and 443 ports. So obviously we have to use application load balancer. And then the other requirement is high performance. High performance means even if you got like sudden load or more number of users, it should provide the same kind of a performance. How can we achieve the high performance? By using auto scale. But the problem with the databases is how the same data will be replicated across all the instances, right? Which is not possible with the auto scaling. So here, what we do is we will follow multi-tier setup. Have you ever heard about like multi-tier setup? What is the meaning of multiple things? Multi-tier means 2 different steps. So here we decided that, let me show. The WordPress application requires web server and database. Web server is nothing but the Apache and PHP. Database is a MySQL. So what we do is we will divide these 2 components and we will maintain these 2 components in 2 different servers. Instead of maintaining all the things in the same server, we will install web server in one EC2 instance. Database will be on RDS, so that the load will be distributed. Only the web server load will go to the EC2 instance. Database load will go to the RDS. Web server performance and high availability can be achieved using the load balancer and auto scaling. And how can you provide the high availability of the database? How to provide the high availability of the database? Because there is no load balancer for the database, right? There is no failover concept using the load balancer for the database. So the database high availability can be maintained using multi-AG deployment. We have a multi-AG deployment for the databases, right? So that we have to use. And we will use EC2 instance only for the web server and the database as a RDS instance. So always the web server will communicate with the database and database will be able to communicate with the web server. Web servers will be managed by the load balancer and auto scaling. And to maintain all these things, you need a network, right? What is the network in Amazon? VPC. So you have to create the VPC. You have to create the VPC. Let us try to understand what exactly we have to create, like how to create the VPC. So let us say we create a VPC here. Wait a second. And do you guess what kind of components we need? Okay, before that, let me give you the overview. High availability can be achieved using the load balancer and auto scaling, right? By using both the things, you can achieve high availability. and high scalability. And here you can see all the instances must exist across multiple availability zones. Because if you maintain all instances in the same availability zone, if that availability zone goes down, you cannot maintain the availability. And then the reliability is obviously the backups. Always we have to configure the backups for production environment. So how to maintain the security? How to maintain the security? By not opening all the ports to the public. Whatever the ports are required or whatever the traffic to be allowed inside, only you have to open those ports from a restricted places. If you open SSH port from anywhere, that is not as secure. If you open 3389 port from everywhere, again, that is not secure. Whenever you are maintaining the public IP addresses, there will be some risk. To avoid that, what we do is, we will maintain everything without a public IP. Even though you create in the public instances, we don't allow the public IP to be exposed to the internet. Then how can we log in? Here we will use a concept called a VPN. We will maintain a VPN server in the VPC. By using the VPN server, we can log in to all your instances using the private IP address. No need to use any public IP. That setup also we will observe. And then for monitorings and alerts, we will use the CloudWatch. So based on these things, how the VPC to be created, like how many subnets, minimum how many subnets we need and all the things, and where we have to place what kind of services, that we can decide, so that from tomorrow we can start creating each and every component. Okay, so first thing, we have to create one VPC. First, we have to create one VPC. Let us say this is the VPC. And we have to give some name, right? Okay, already I documented all the steps. So whatever I'm going to discuss, that will be available as steps in the document. I will share the document so you can go through the document. Okay. So here we have to give some name, right? I will give the name as, you can give any name, that doesn't matter. My prod VPC. This is the name I am going to give. And we have to select a CIDR block, IP address range. The range I will choose 10.0.0.0/16. Okay. And then the immediate thing what we need is internet gateway. We need one internet gateway. We have to create the internet gateway and we have to attach. And then we have to create the subnets. How many subnets we need? Minimum 2 subnets, one public and one private, right? Okay. Let us say, as you said, so this will be my public subnet. Okay. And let us say, this is my private subnet. Now, where I need to launch my web server? Obviously in the public subnet. Okay. So if I create my web servers in the public subnet, every EC2 instance will be in the same subnet. The subnet can be created in a single availability zone. So how can you maintain the high availability? You cannot, right? So that's why what we do is, we will create 2 public subnets. 2 public subnets, public 1 and public 2. You can give any name, that doesn't matter. So here we have to choose the IP range. I can choose like this. And for this, I will choose 10.0.2.0/24. And then the private subnet, I will create private 1. And here, what will be the IP address? IP address range. You can use 3.0, 4.0, whatever it is. But I will choose 11.0. The reason is, going forward, if I need one more public subnet, so that I can use 3.0 for the public, like from 1 to 10 public subnets, 11 to 20 private subnet, easy to manage. But if you create 3.0 as a private, there is no wrong in that. You can create in that way also. Okay, and then here, I will create one more private subnet, private 2, and I will give the name as 10.0.12.0/24. And one more important thing is, while you are creating the subnets, these subnets to be created in two different availability zones. If you create both in the same availability zone, there is no high availability. And all these subnets requires route tables, right? Okay, now the question is, do I need to create 4 route tables? No. Can I create one route table? Even in that case also, it is not possible, because if I create one route table for all, if I create a public route, automatically the private one and private 2 will become public subnets. So that's why what I do is, I will create or I will maintain 2 route tables. One is for public subnets. This is the route table, and we will name it as public RT. By default, you will get a route like 10.0.0.0/16, and target will be local. This will be the default one, right? But we will create one more like 0.0.0.0/0 through internet gateway, like this. Then we will attach these 2 subnets with this route table. And then we have to create one more route table. This will be the private RT, right? And here, by default, you will get 10.0.0.0/16. The target will be local, and we will attach like this. Automatically, these all the subnets in the same VPC will be able to communicate with everything. And here, what we need is, we need to maintain internet connectivity in the private subnets. That's why we will prefer to create a NAT gateway, so that here we will create another route through the NAT, so that all your private subnet instances are able to browse the internet. Okay, so then my goal is to create EC2 instances here, 1 and 2, and these instances will be maintained in a target group. And here we will have a application load balancer in the public subnet. Actually, I have to mention this in the public subnet, and this will be connected to the target group. So whatever the load is coming here you will get a DNS name, right? The users will be able to communicate with the load balancer, and the traffic will be distributed across both the web servers. And for maintaining the high scalability, we will maintain auto scaling also, right? Auto scaling part requires a launch config and an auto scaling group, right? These two will be interconnected, and the auto scaling group will be connected with the target. So whatever the instances got created, they will be automatically added to the target group, and so that the load balancer can handle all the load to be distributed across all the EC2 instances. And our WordPress requires a database, right? So that database we will maintain in the private subnet, and we will create that using multi-AZ deployment. These two will be interconnected. One is always a primary, and the second one will be a kind of a standby, right? And these EC2 instances always points to the primary instance. If the primary fails, automatically the standby will become primary, and it will provide the services to your web server. This is how a typical infrastructure looks like. But I don't want to allow any security groups to be open to the public. That's why here we will maintain a VPN server. What will happen here? To log into the EC2 instance, the user first has to log into the VPN with using their username and password. There will be a separate VPN username and password. Then this user can log in to the EC2 instances or the database servers using the private IP address. The public IP will not be exposed to the internet. Okay. So here, what are the different components will have a security groups? What all the components of services will require a security group? Because the security will be depending on the security groups, right? We don't touch the NACL. We don't touch NACL. We will keep the default NACL itself. But the security groups, we have to secure all the infrastructure by providing maximum security. Okay. So first let us come here. And also one more thing I forgot, we will maintain one management server. What is that management server? An empty EC2 instance, which we can use to install your tools or softwares, so that from here you can log into any server or you can run some reports or whatever it is. But we will create that, but we don't use it. Sometimes you need to log into the database to check the data, right? So somewhere we have to log in. Here, from here also you can log in, but there will be some latency. That's why we can log in there. You can install your MySQL community tool or SQL workbench, whatever it is. From here, you can log into the database and you can check the data. So first thing is the load balancer, right? The load balancer will have a security group. And then VPN server will have a security group, because that is nothing but an EC2 instance in which the VPN software will be installed. Then the NAT gateway. Does NAT gateway will have a security groups? No. NAT gateway doesn't have any security groups. Then EC2 instance. It requires, right? So this EC1 and 2 EC2 instances are web servers. Web server EC2. Then management server. Then RDS instances. They need a security group, right? And what else requires a security group? That's it. Okay. So now first thing is application load balancer. In the application load balancer, what ports to be open? First thing is, let us say, application load balancer. What ports we have to open in the application load balancer? So here, the user will access the application through the load balancer. That means he will open a browser. He will type the URL of the application load balancer. By using which protocol the traffic will be sent? HTTP and HTTPS, right? Okay, we have to open 80 and 443 ports. From where we need to open that? From where we need to open the 80 and 443 ports? From where? Only from your office? Anywhere, because you cannot ask everybody to come to your office to access the application, right? We have a Gmail application, right? Are we going to the Google's office to access? No, from anywhere. So 80 and 443 port of the load balancer must be opened from anywhere. And what about the VPN? We don't know much about the VPN. So we cannot decide at this moment. But at the time of installing the VPN instance, it will show you what are the ports required. Those ports will open by default. Then web server. What ports to be opened on the web server? What ports to be opened on the web server? Okay, let me simplify that. So here you will have a load balancer, application load balancer. And then here you have a web server, which is a web server. And then you have a database here, RDS. Load balancer will be connected to here. It will be connected like this, right? And we have what we have? We have a management server. And this will be connected to, from here, the traffic to be allowed. Okay. So web server. This is a Windows. I am deciding to use a Windows server, because in the EC2 also, to install a web server, we use a Linux. We never use the Windows as of now. So we will choose the Windows. So in this security group, what are the ports we have to open? So, okay, we have to open the RDP, because initially we need to log in to prepare the machine, installing all the required tools. Then Actual web application is running on the web server, right? Here, the user is there. The user will be connected to the load balancer. From the load balancer, the request will be forwarded to the web server. Obviously, the user's 80 and 443 request will come to the web server. So on the web server, we have to open RDP, HTTP, and HTTPS. Now the question is source. From where we need to open the RDP port? Can I open RDP port from anywhere? No, you should not. I mean, if you open it, that is not as secure. So all these are in a VPC, right? So here, what is the VPN is, if any user connected to the VPN, the user will be considered as that he is present in the same network. So now what I do is, I will open the RDP from the VPC network only. From the VPC network only. Whenever the user logged into the VPN, he will be considered into the VPC. So obviously he is sending the request using the VPN server. So obviously the request will be initiated from VPC network. So if the user connected to the VPN, then only the RDP traffic will be allowed. Now the HTTP, which is 80 and 443 ports, from where these two ports to be opened? Anywhere. Okay. Let us say if I open anywhere, what these users will do is, instead of accessing through the load balancer, they can directly communicate with your web server. Then what is the use of a load balancer? So you should not open from everywhere, right? So now in this Windows server, from where we are trying to allow the request on 80 and 443 ports. The request must come from the load balancer only. So what I do is, the 80 and 443 ports to be opened from application load balancer only. But the load balancer doesn't have any IP address, right? Then how? This load balancer will have a security group, right? So in the source, we will use the load balancer security group name. What is the meaning of that is, if the request is coming from an instance which is using so-and-so security group, then only the 80 and 443 traffic will be allowed. So that the 80 and 443 traffic will be allowed into your web server if the request is coming from the load balancer. And then the next will be RDS, right? So from where RDS means, we are using MySQL, the port number will be 3306. From where this 3306 to be opened? Initially, by default, we will create the database as a private, not publicly accessible. Now the question is, from where the 3306 port to be opened? VPC. Why? Okay, let us say in your VPC, there is one more EC2 instance which belongs to a different customer. Then that EC2 instance might be able to communicate, right? Again, that is not the good one. Then web server to be communicate with the database, to load the data or to create the data. Like you can use VPC also, but that is not highly secure. So the request to be accepted from the web server. So you can say that I will mention the IP address of the web server. But what if you have a multiple web servers? Because auto scaling will launch a new EC2 instance. You cannot guess what is the IP address. That's why we will mention that on the RDS security group, the 3306 port to be opened from the web server security group. We will mention the name of the secure web server security group. So the application, there is no issue. Application web server is able to communicate with the database. But the user wants to generate some reports by loading the data from the database. So you can say that the user can log into the web server and from there he can. But if I log into the web server, if I am doing some additional activities, the CPU will be utilized more. The web server performance will go down. For that reason, we will maintain a separate EC2 instance and we will name it as management server, or we can call it as a gem server, whatever it is, that doesn't matter. A plain Windows EC2 instance. So the database to be accessible from the management server also. That's why the 3306 port, 3306 port to be opened from web server security group and management server security group. Now coming to the management server, what ports to be opened from the for the management server security group? What is the use of management server? This user can log in and then he will do something. So RDP port is enough. From where we need to open the RDP port? Not from anywhere. Same as like this. Only from the VPC. Even this user can log into the management server if he got connected to the VPN. What will happen if I open the management server to the public? By any chance, if someone is able to log into the management server by cracking the password, they can access all the databases and everything. But if you use a VPN, they have to guess the VPN password first. Then they have to guess the management password. So there's like additional layer security. Right. And what else we have? What are the other security groups? Management server, RDS, web server. Okay. So always you have to open the security groups only from a specific, what we call that, allocations according to the requirement. Always we will open 80 and 443 ports on the load balancer from anywhere. Again, on the web servers, the 80 and 443 ports to be opened only from the load balancer. If you see that concept, it will looks like, so this will be the target group. This will be the target group in which you will have what we call multiple EC2 instances. Let us say 2 EC2 instances, 1 and 2. Website is running and it will run on 80 and 443. And we are using a load balancer. Okay. So here there is a security group. And for these, there will be a security group, right? Like it will be connected like this. So here the 80 and 443 ports to be opened from anywhere. What if you open 80 port from anywhere? Here is the user can directly access the website, which is not good. That's why we will open the 80 and 443 only from ALP. Then how it looks like? The request will first come here. So anywhere. So this user is able to get into the load balancer, and the load balancer will send the 80 request on server 1, which will be accepted, and 443 request on 2, which will be accepted. Always you have to open the security groups with minimum required permissions. This is the basic overview. Now I will show you the document and I will explain what all the steps we are going to do. And here initially, to deploy the auto scaling, we have to create a launch configuration, right? Without having a launch configuration, you cannot do the auto scaling. But in the launch configuration, it requires AMI, right? From where we will get the AMI? From where we will get the AMI? Because Amazon don't provide that. They don't know what is your requirement. You have to prepare the AMI. For that, what we do is we will create one temporary EC2 instance in the same public subnet. And you can log in and you can install everything. And we have to test that the application is working fine or not. But in the security group, we didn't open 80 and 443 ports from anywhere, right? That's why we will add the temporary EC2 instance in the target group, and through the load balancer, we can access it. Once we are done with all the components installed, we will create the AM, and then we will delete this temporary EC2 instance. So we can create launch config, auto scaling group, database, everything step by step. And also to create these EC2 instances, we need the key pair. Key pair, right? For the web servers, we will create key pair 1. For a VPN server, I will create one more key pair. For the management server, I will create another key pair. And for the RDS, do we need a key pair for the RDS? Not required, because at the time of creating the RDS, we will assign the password directly. So these are the different components we are going to create. And finally, we will use CloudWatch, SNS notifications, alerts, alarms, everything we have to create manually. Okay. So first, let us see what are the steps we are going to perform. Just I will give you the quick overview so that we can start creating that infrastructure from tomorrow. I will share this document immediately. So just go through all the document. And in the next session, if you have any questions like why we need to create in that way, why not in a different way, those questions you can ask. Okay. So first, we need to start with the virtual private cloud, because the VPC is a network. Without having a network, you cannot create any services. So we will create a VPC, and I will give the name as my prod VPC. And I will decide Northern Virginia region to deploy this application. Or if you need Mumbai, you can go with the Mumbai also. And I will use this CIDR block. This will be my VPC network. Once you create the VPC, then you have to create the internet gateway, and you need to attach that internet gateway to the production VPC. And the next step will be the subnet creation. I will create a public one subnet in 1A availability zone with this CIDR block. And then I will create public 2 subnet in 1B availability zone. This is mandatory. You have to create the subnets across different availability zones. Otherwise, there will be no high availability. And this will be the CIDR block. And for these 2 subnets, I will create a route table called public RT. And in that public RT, we need to create some additional routes in order to make that route table as a public route table. Then the public 1 and public 2 subnets will be associated with the public RT route table, so that the public 1 and public 2 will become the actual public subnets. The moment once you create a new route table, you will get the default route. This is the default route. We don't create that. By default, the default route will be available. What is the use of the default route? The use of the default route is to enable the communication across all the subnets within the VPC. Then we will create the route, which is mentioned in the bold letter, bold color. This is for to convert the route table into the public. Once you create the route table, you have to associate the public 1 and public 2 subnets with the public route table. And in the same way, we have to create the private route tables, private subnets, and we decided to use a NAT gateway for your private subnet, right? So first thing, we will create a NAT gateway in the public 1 subnet, but the NAT gateway is not a free tier eligible. So if you don't want to get charged, you can go with the NAT instance, so that you will not be charged. Then you can use a private subnet, private 1 subnet, private 2 subnet. The same thing we will repeat, but in the additional route, instead of internet gateway, we will use NAT gateway, so that your subnets will become a private subnets and they can get the internet connection also. Once the route table got created, we have to associate the private 1 and private 2 subnets with the newly created private RT route table. Now we need to create the VPN server, because after that, if you create a EC2 instance, to manage the EC2 instance also, you need to log in, right? And we decided not to create or not to open any ports to the public. And the VPN server requires an elastic IP address, because if you restart the computer or if you stop and start the VPN server, the IP address will get changed. So I need a fixed public IP. So we will assign or we will allocate one elastic IP address, and then we will create the VPN server, and I will give you the steps, how to install, how to configure, how to create users for every employee, and every employee in the sense whoever require access to the VPN server. And then we will log in and configure the VPN software. So we will be done with a basic creation. Then we will create the security groups, application load balancer, and I will give the name as ALB-SG, management server, web server, and RTS. These are the 4 security groups we need. Because here for the VPN server, we created the security group at the time of creating the VPN server itself. And here, see here, let me minimize. Okay. This first one is the application load balancer security group. What we have done there, we opened 80 and 443 ports from everywhere. You have to write these two. Always, whatever I mentioned here, all those are incoming rules. By default, outbound traffic will be allowed. No need to restrict that. These all are inbound traffic, inbound rules. In the application load balancer security group, we will open 80 and 443 traffic. And then in the management server, which will be a Windows server, we will open the RDP traffic from the VPC itself. That means if the user connected to the VPN, then only he can log into the management server. Directly, they cannot log in. And here also, the user can use the private IP address to log in. No need to use public IP. Then for the web server, security group, I will open the 3389 traffic only from the VPC, and 80 and 443 ports to be opened from ALB-SG, which is a security group of the load balance. And then the database security group, the 3306 traffic to be opened only from the web servers and the management servers. So you can mention the name of the security group. Then the key pairs, web server requires a key pair, management server requires a key pair. Generally, while you're creating the web servers, you can create, but we will create in advance and then we can proceed with those things. And then we have to create the database. With these details, we will create. But here there is one small change. Generally, in the real time, for the database, we don't use the GP2. We will use IO1 or IO2, provisioned IOPS, because in which you will get more IOPS. But the problem is the IO1 or IO2 is not free tier eligible. That's why I will select GP2. Generally, for the databases, provisioned IOPS SSD is recommended. Okay. So while creating the database, we will give the instance name as this, like instance identifier. And then this will be the database name, username, password, multi-AG to be enabled, database engine to be MySQL, automated backups to be configured with 7 days retention, enhanced monitoring to be enabled, and DB instance type, you can go with as per the requirement. But here I will go with T3.micro. And then auto scaling for the storage, I will enable for high scalability up to 1000 GB. And then we have to create the load balancer, and load balancer will have two components, target group and load balancer. We need to create it, and you need to note down the DNS name of the load balancer. Then Route 53, which is optional. This is only required if you have a registered domain name. Then what we do is, if you let us say you are the owner of abc.com, then in the Route 53, we will create alias record so that the abc.com will point to this load balancer DNS. So your web application will be accessible using abc.com. But we don't have that particular domain name, so we will use the DNS name itself. This part we will skip. But in the real time, you have to create the alias record so that your actual domain name will be pointed to the load balancer, so that the users can access your website using the abc.com domain name instead of this randomly generated load balancer URL. Then we have to create a web server, but it requires web servers to be created using the auto scaling, and auto scaling requires a AMI, right? So that's why we will create one temp server with t2.large Windows Server 2019 with these details. And I will use a tag called backup is yes, because we need to create the automated backups for EC2 instances using the lifecycle manager in the EBS that requires a common tag, so that all the EC2 instances with that tag will be automatically backed up on a daily basis. So you will create the web server and you will install all the required things. And we will add that EC2 instance into the target group so that the application running on that EC2 instance will be accessible using the load balancer URL. Once you log in, we will install the XAMPP software and we will install the Apache as a service so that whenever you reboot the computer, the Apache service will be started automatically. Otherwise, you have to manually log in. Then what we do, we will download the WordPress application and we will extract it and we will place into this particular folder. In the Linux, for the HTTP website, we place it in var www.html, right? In the same way for the XAMPP software, for the XAMPP web server platform, you need to place the WordPress application in this particular directory. So once you place that, everything is ready. The WordPress is ready to configure. You have to use the website load balancer URL to access because we don't have a registered domain name. And you have to follow on-screen instructions to configure the WordPress application. Then we need to create AMI. And we can terminate the temp server as we don't need that. Then we have to go with auto scaling, like launch configuration and auto scaling group. While creating a launch configuration, you have to select the AMI, what type of instance you need to use, purchasing option, whether on demand or a spot, whatever it is. Monitoring to be enabled with detailed monitoring. EBS volume size, they will mention, I will go with 50 GB, security group and keep it. Then auto scaling group. Here you have to mention which launch configuration to be used, in which VPC you would like to create, in which subnets you would like to create them, and in which target group you would like to add, what is the group size, like minimum with how many instances the fleet to be created. Whenever the CPU is more than 60%, would you like to create a new instance? Yes. Up to how many you would like to create? Up to 6. Whenever something is happening with the auto scaling, I would like to receive a notification on my email. So I will use the SNS here. And then we need to log into the WordPress and we will create some post, we will delete some data and all the things. And if you are able to put some load on your web server, automatically the third EC2 instance will be created. Then we will do some kind of high availability, like how I will delete one EC2 instance. Automatically a new EC2 instances will be created and there will be no downtime. Okay, that we can observe while we are done with the infrastructure creation. These are the different components we are going to use. What all we are using? EC2, EBS, load balancer, auto scaling, RDS, SNS, CloudWatch, and VPC. VPC is a basic thing, right? And VPC. These are the multiple services we are going to use to deploy a simple WordPress application. To maintain that application to be highly available, instead of using a regular security group, we are hardening the security group by only opening the required ports from a limited sources, not from anywhere. Okay, so this is what we are going to deploy in the next coming 3 days. It will take minimum 3 days to create, because everything we need to discuss, like how to create and all the things. I guess all these topics we covered, right? So if you have some time, just try to understand that and try to create on your own. From tomorrow onwards, I will start creating with the first step, which is a VPC creation. Where is that? Yeah, from here, we are going to create. And then the most important thing is the architecture. You should not maintain everything in the same availability zone, and you should not maintain the databases in the public subnets, because that is not required. Okay, right. So these are the components we are going to use. And at least have you got some basic idea about how to maintain an infrastructure to be highly available, secure, and reliable? And go through the document. I will upload the document right now. Okay. And if you have any questions, just you can ask me on that. And if you have any questions right now on this environment, just you can ask me right now so that we can discuss about that, and we can get some clarity on like why we are creating in that way. Whatever the point you read, just try to question yourself, like why to create a two public subnets and why to create two private subnets. Why don't we create the database in the public subnet? Just ask a question about the statement so that you will get some clarity. If you don't get some clarity, let me know. I can help you on that. Okay, and I will upload the document right now. So I will create a new folder like a project, and I will upload the document into that. And I will create a diagram also, like what all components we are going to use. In that, I will upload the image also so that you will get some clarity on how the communication is going and all the things. Okay, right. So I am uploading right now. Just you can get the document in just 5 minutes. Okay, before that, any questions? Anybody having any questions? Okay, I uploaded the document, just check it. And if you guys are clear, let us stop the session and let us continue tomorrow. So tomorrow we can start creating all the infrastructure and we will start deploying our WordPress application. Instead of WordPress application, you can go with any kind of application. If you have some Java application, you can deploy that also, but the requirements might be vary. Like instead of what we call that Apache web server, you might have used a Tomcat server. You have to install the Tomcat. Or if you are using a .NET application, then you have to use Microsoft IIS web server. But the architecture, VPC, subnets, private subnets, load balancer, that concept will be the same. There is no change in the infrastructure. The only change with the services or the softwares which you are going to use in your EC2 instances. Because you cannot run a Java application using PHP software, right? Okay. Right. Any questions? Okay, then let us stop the session here. Let us continue tomorrow. Okay. Thank you, everyone. We'll continue tomorrow.